behavior. Now we will learn about application of semaphore in the bounded buffer problem. So the bounded buffer problem is that there is a producer, there can be multiple producer, and there are consumers, there can be multiple consumer, and there is a fixed size buffer. It works like a queue. Whenever a producer produces something, it pushes the value in the queue. Whenever the consumer consumes a value, it pops from the queue. So producer generates piece of data and put it into the buffer and start again. Consumer removes data from the buffer. So producer produces something and push it in the queue. Consumer pops out the data from the buffer. So producer produces till buffer is not filled up, or consumer consumes until the buffer is not empty. Okay, so concern one, producer won't produce data when the buffer is full, consumer won't remove data when the buffer is empty. So this is the bounded buffer problem, and here is the solution using the semaphore. We already saw this using lock. So producer produces an item. If the item count, the initially count value, if the item count is equal to buffer size, it will sleep. That means it will do nothing. Otherwise, it is put into the buffer and item count will be plus plus. And consumer, item count equal 0, it will sleep. That means it will do nothing. Otherwise, it will remove from buffer. Item count will be decremented. That means we consumed an item. Uh, this is the new code for you. Whenever the buffer is full, whenever the buffer is full, the producer will go to sleep. It will do nothing. Whenever the buffer is full, the producer will go to sleep. Whenever the consumer says consumer says the buffer is empty, the buffer size is 0, it will go to sleep. Okay. Item count, buffer size equal buffer size. That means the buffer is full, then the producer went to sleep. When item count equal 0, that means there is buffer is empty, the consumer went to sleep. Now if item count equal buffer size minus 1, item count equal buffer size minus 1, that means there is at least one empty spot in the buffer, the consumer will wake up the producer. That means I consumed one item, you can produce now. So the initially the producer was sleeping. Whenever the consumer consumes something, there is at least one empty spot, the consumer will wake up the producer. Like that, when the item count equal 0, that means the buffer count buffer is empty, the consumer will go to sleep. So if item count equal 1, that means there is at least one item in the buffer, the producer will wake up the consumer to consume the item. So this is the new addition. So we will not keep checking again and again in the while loop, rather we will sleep and the other will wake up it. So if the buffer size fill, the producer sleeps. Whenever there is an empty spot, the consumer wakes up the producer. And if the item count equal 0, consumer sleeps, the producer is waking the consumer when the item count equal 1. That means there is at least one item to consume. So producer sleeps, consumer sleeps, wakes up producer, wakes up consumer. So there is a dependency or cross connection. Okay, consumer sleeps by itself and the producer wakes it up. The producer sleeps by itself and the consumer wakes it up. So there is a cross connection. So initially the solution looks okay, but there is a problem named deadlock. At first we understand this, how deadlocks work. So if any process sleeps, another process can wake it up. If any process falls asleep, another process can wake it up. So before the sleep function needs to be executed, then the process will go to sleep, and after that when you call the wake up function, it will restart again. So the order is you need to go to the sleep at first, then another process will wake you up. So the order is at first you need to call sleep and then you need to call wake up. What if the order is not maintained, then we will face the deadlock. That means, let's say there is two semaphore, let's say S, let's say Q. S is equal to 1, Q is equal to 1. There is two process P0, P1. Okay, P0 and P1. So uh, now just a minute. Let's say P0 called wait. At first P0 called wait. Then P0, let's say P0 is executing this code, P1 is executing this code. Let's say P0 at first call the wait. So whenever wait function is called, the value of semaphore will be 0, will be decremented. And then P1 was scheduled. It called the wait queue. So it is also 0. Then it is descheduled. Again, P1 is scheduled and it calls the wait function queue. That means it will stuck in the while loop or stuck in sleep. Then P1 got scheduled and it called wait. Yes, it is already stuck in sleep. Why? Because the value is already 0. So both of the processes went to sleep state. So every time you call the wait function, if the value is less than equal 0, it is blocked and go to the sleep state, and if it is as greater than 0, then it will decrement the value of s. Initially s was greater than 0, that's why it was decremented. Initially q was greater than 0, it was decremented, but after that p0 called wait q, it is stuck in sleep. It p1 called wait s, it is stuck in sleep. So there are some signal functions. There are some signal functions. P1 can wake up if someone calls signal Q. P1 can wake up if someone calls signal S. P0 can wake up if someone calls signal Q. P1 can wake up if someone calls signal S. P0 was assigned to call signal S. P1 was assigned to call signal Q. If someone calls signal Q, P0 can restart. If someone calls signal S, P1 can restart. But P0 was assigned to call signal S, P1 was assigned to call signal Q. That means P0 is waiting for P1, P0 is waiting for P1 to call signal Q. P1 is waiting for P0, P1 is waiting for P0 to call signal S. So that means P0 and P1 both are waiting until another is called the signal function. So this is known as deadlock. So deadlock is when every process in the set is waiting for an event that can be caused only by other process in the set. So here P0 and P1 can wait indefinitely for an event. P0 is waiting for P1, P1 is waiting for P0. So both of the process are in the waiting state and both are waiting for each other. So they can wait indefinitely. So this is known as deadlock. This is known as deadlock when each process in the waiting state is waiting for each other. So this is known as deadlock. So another thing is named starvation. That means a process is waiting indefinitely within a semaphore. So a process is waiting in the semaphore indefinitely. It is known as semaphore. Starvation. So it can occur if we remove a process from the semaphore list using the LIFO manner. Let's say P1 called wait function. It was put in the list, waiting list. Then P2 called the wait function. It was put in the list, waiting list. Then P3 called P3. P3 were put in the waiting list. Then a signal is called. Then we removed the process in LIFO manner. That means we removed P3 from the list. Then P4 again called waiting function. P4 was stored in the waiting list. Then again another signal function was called. Then P4 will be removed. That means P1 is waiting indefinite amount of time. So this is known as starvation. So we learned about deadlock and starvation. So in this code there is a case where deadlock can happen. Let's say let's say mm, let's say initially the consumer is scheduled. So it will check item count equal 0. Initially the item count equal to 0 as no item in the buffer. So initially the consumer was scheduled and it check item count equal 0. If item count equal 0, then it will place itself into sleep. If there is no item in the buffer, it will go to the sleep state. But the problem is that before going to the sleep state, it got interrupted. And producer was called. So producer will create an item, buffer is not full, so it will not execute it. Then it will put the item in buffer, item 1, item count plus plus, item count is equal to 1. Then if item count equal 1, it will wake up consumer. So it will try to wake up consumer. As no consumer is in the sleep state, this wake up function will do nothing. This wake up function will do nothing. Then consumer is scheduled again. Then it will start from this line. It will put itself in the sleep. So the consumer went to the sleep state. So we at first call the wake up function, but it did nothing as no one is sleeping. But after calling the wake up function, the consumer went to the sleep state. The consumer went to the sleep state. So this is the case when you are stuck in that deadlock, because after certain time the buffer will be full, and when the buffer is full, the producer will go to the sleep state also. Then consumer is waiting in the sleep state to be waked up by the producer, and producer is in the sleep state waiting for consumer to wake him up. So this is the condition where you can stuck in a deadlock, because the order was not correct. You called wake up before the sleep function. That's why consumer went on a indefinite sleep state, and after some period producer will go to the sleep state for indefinite time. Producer is waiting for the consumer to wake him up, and consumer is waiting for the producer to wake him up. So if the wake up function is called before the sleep function, then there can be a deadlock situation. So in this bounded buffer problem, the solution is inadequate. So you need to be very careful whenever you are using semaphore. There can be easily a deadlock state. So how to mitigate this issue of this deadlock? So we are using the same count variable to check producer is sleeping or not and consumer is sleeping or not, or to wake up the producer and to wake up the consumer. We are using the same count variable or count semaphore. So basically we need to use two different semaphore. One is count fill, one is count empty. So count fill means number of available item in the buffer to be consumed, and count empty is number of available space in the buffer to write or buffer to fill up. So if you use two different count variable, so one to track the available item and one to track the available space, then the problem can be mitigated. So this is the correct solution. So count full tracks the number of available items, count empty numbers the available space. Initially count full is equal to 0, that means there is no available item in the beginning, and count empty is available space, which is the buffer size, that means the whole buffer is empty. And mutex is the semaphore, it is used to guard the buffer. So as buffer is a shared variable, here producer is also using the buffer, consumer is also using the buffer to put or to retrieve value. So to guard this shared variable, you need another mutex. So that's why the mutex was used. Initially no one is using the buffer, that's why the mutex is 1. So in this solution the previous problem was mitigated. Now we will